Students, welcome. Previously, Form 2, Topic 2, Lesson 3, we were dealing with physical properties of alkali metals. We have done the melting and the boiling point of alkali metal, the fast ionization of alkali metals, and we have done the electrical conductivity of alkali metals. So today, Lesson 4, we are going to do chemical properties of alkali metals. So we start with number 1, reaction of alkali metals with air or with oxygen. So we are going to start with the lithium because we are going to use the first 3 members of alkali metals which are found in the first 20 elements in the periodic table. So lithium plus oxygen, we are going to get lithium oxide. Remember, when a metal reacts with oxygen, we get metal oxide. So here we are having Li, which is the chemical symbol for lithium, plus oxygen. Remember, oxygen is one of the elements that are diatomic gases or exist in a molecular form, elements that exist in a molecular form. So we are going to get lithium oxide. To write lithium oxide, you have to know lithium and oxygen, their chemical formula or their chemical symbol, They know the valency of lithium. Lithium, we said, is an alkali metal. It has 1 electron in its outermost energy level, so it will lose rather than gaining 7. And that's why they are monovalent. That's what you have said in our introduction side of alkali metal. So the valence of lithium is 1, the one for oxygen is 2. So if we interchange, we are going to get 2 on the side of lithium, 1 on the side of oxygen. So we are going to get Li2, then O, because we don't write 1. So the state is solid. So we have to balance it by putting 4 on the side of lithium and 2 on the side of lithium oxide. So we have 4 lithium, we have 4 lithium, we have 2 oxygen, then we have 2 oxygen here. So that's the reaction or the chemical equation for the reaction between lithium and oxygen. So next, observation made when that lithium burns in oxygen or in air. We are told lithium burns in oxygen with a deep red flame to form a white solid, or you can say crimson here. Lithium burns in oxygen with a crimson flame to form a white solid. Reason for the white solid, we are saying this is because lithium reacts with oxygen to form lithium oxide, which is a white solid. So in chemistry, to explain observation is very simple because you only talk about the reaction. So lithium reacts with oxygen to form lithium oxide. So lithium oxide is the one that has the white solid or the white color. Next, we are going to go to sodium. So if you know what happened in lithium with air or with oxygen, it's the same as what will happen in that side of sodium. So to write the reaction, we're having 4 of sodium solid plus oxygen gas, we get 2 of sodium oxide. So the way you balanced in that side of lithium will be the same that you're going to balance in that side of sodium. Observation. Sodium burns in oxygen with a yellow flame to form a white solid. Reason? This is because sodium reacts with oxygen to form sodium oxide, which is a white solid. So even the reason will be just the same. The observation is just the same, only the difference will be the color of the flame that they are going to burn with. The rest, they're just the same. The white solid is the same, and the reason for the white solid is again the same. But note that sodium burns in air enriched with oxygen to form sodium peroxide. So sodium plus oxygen, you can get sodium peroxide, and 2 of sodium solid plus oxygen gas will give you 1 of sodium peroxide. That equation is balanced when we put 2 in the side of sodium, and that will be balanced. We get 2 sodium here, 2 sodium on product side, we get 2 atoms of oxygen on the reactant side, and we have 2 atoms of oxygen on the product side to balance the equation. So next we go for potassium. So it will be the same again. Potassium will react with oxygen to get potassium oxide because metal plus oxygen, we get metal oxide. To balance the equation, we are going to have 4 of potassium. To write balance the chemical equation, plus oxygen gas, we get 2 of potassium oxide, which is solid. So you only know how to write lithium oxide or the reaction between lithium and oxygen. Then what you do only, you remove the chemical symbol for lithium, then you replace with that of sodium if you are dealing with the reaction between sodium and oxygen, or if you are dealing with the potassium with oxygen, you only replace that Li, which is the chemical symbol for lithium, with K, and the balancing will be the same. And that is the reason because all of them are a member of alkali metal. That means they have 1 electron in their outermost energy level, which make them to have similar chemical properties. So the observations made, potassium burns in oxygen with a lilac flame to form a white solid, and the reason is the same. This is because potassium reacts with oxygen to form potassium oxide, which is a white solid. Next we are going to go to number 2, and number 2 we are having reaction of alkali metals with chlorine. So when a metal reacts with chlorine, we get metal chloride as our product. So we start with lithium. So lithium plus chlorine, we get lithium chloride. So lithium is written Li as its chemical symbol, reacting with chlorine. Remember, chlorine is one of the elements that exist as a molecule. So when you are writing chemical equation, you write Cl2. Then we are going to get lithium chloride. Lithium, the way we have said, has a valence of 1. Then chloride ions or chlorine has a valence of 1. So when you interchange, we are going to get 1, 1. So the way you write is LiCl, which is solid. So to balance, we put 2 on the side of lithium and 2 on the side of lithium chloride. So we have 2 lithium on product side. We have 2 chlorine on the side of a reactant. Then we have 2 atoms of chlorine on the product side. Okay, the observations made when a hot lithium metal is lowered into a gas jar containing chlorine gas, we are seeing lithium metal continues to burn with a deep red flame to form a white solid. Reason? This is because lithium reacts with chlorine to form lithium chloride, which is a white solid, or you can say a white fume, Next, we go for that side for sodium. You do the same. Sodium plus chlorine, we get sodium chloride. Writing the chemical equation, it will be like this, balanced chemical equation. So we go for observations made when a hot sodium metal is lowered into a gas jar containing chlorine gas. So the observation is sodium metal bursts into a flame and a white solid is formed. Reason? This is because sodium reacts with chlorine to form sodium chloride, which is a white solid, or you can say which is a white fume. So a white fume of sodium chloride will be formed. So next we are going to go to the side of potassium. So when potassium reacts with the chlorine, we are going to get potassium chloride. How are we going to write the chemical equation? We are going to write the way that we have written in that side of lithium plus chlorine and also sodium plus chlorine. What we are going to change is only the chemical symbol for Li for lithium to be K on the side of potassium. The balancing will be just the same. So what about the observations made when hot potassium metal is lowered into a gas jar containing chlorine gas? We are seeing a potassium metal bursts into a flame and a white solid or a white fume of potassium chloride is formed. Reason? This is because potassium reacts with chlorine to form potassium chloride, which is a white solid or which is a white fume. That's the end.